Salutare tuturor și bine ați venit! Numele meu este Bogdan Popescu, sunt Director of Engineering în cadrul Deloitte Digital și astăzi o să începem primul eveniment dintr-o serie de evenimente Powered by Deloitte Digital cu scopul de a ajuta piața locală de IT din România. Alături de mine l-am pe Laurentiu Spilca, majoritatea, de fapt cred că toți îl cunoașteți. Îi mulțumesc în primul rând că s-a oferit și a fost de acord să ne ajute cu această inițiativă. O să las pe Laurentiu să vă spună părerea lui personală despre best practices, Spring Security și toate lucrurile la care se pricepe cel mai bine. Așa că vă urez vizionare plăcută și interacțiune plăcută cu Laurentiu.
Cool, thank you very much. So I hope you don't mind if we continue in English, because I think we will have a bunch of people who don't understand Romanian up there in the online. Thank you very much everyone for welcoming me here. That's the first thing I want to say, is that I'm a little bit nervous. I didn't feel this for at least a couple of years since the pandemic started, but now I'm in person here and I'm talking to you, and this is very important for me. Thank you very much for welcoming me. We will discuss about security, and especially today about Spring Security, some practices, some small but very relevant things that you need to know and that I'm going to share from my experience. I met you here, a lot of you, excellent environment, very nice people. The opinions are mine and only mine, but you trust me. Let's start the discussion, and I would like to first share with you a few slides, but that won't be too much, because when they offered me the opportunity to come here and discuss with you, they said, Laurentiu, we don't want slides, we want only code. I said, okay, maybe a little bit of slides with some visuals first, because we need them, but we will continue coding, and I even have, where it is here, so I even have a nice null pointer exception for you here, so you will see what's about it when I'm discussing about that terminal window. Don't hesitate to ask questions. You in the online, guys, don't hesitate to ask questions as well. I will see your questions here. I have Christy helping me, and I will try to answer them during the presentation, so you don't have to wait up to the end. Just raise your hand if you are in the audience. Just write your question if you are there in the online, and I will try to answer it during the presentation. Of course, we also have some prizes for both the people here and in the online. Tickets at Vox Days, books, some paper copies, and some online tickets, vouchers, e-vouchers that you can use, and we will share them as well after the presentation. Okay, too much talking. Let's start. So we discuss about security, and the security. Whenever you ask someone what security is, usually they tell you something else. If you ask 100 people what security is, they will tell you different things. It really depends on if you are a network engineer, if you write an application, if you are an infrastructure guy. For someone, security might be deploying securely containers into Kubernetes, implementing correctly that Istio service mesh, simply managing correctly the packets at the OC level if you are a network technician, or it might mean authentication and authorization if you are an application developer, and that's mostly what we will discuss today. I'm going to structure this presentation into 3 parts. We will first discuss about the very fundamentals of the framework, and as I put in one of the next slides, you will see the best practice of the best practices is knowing very well the framework you are using, and that's covering any kind of framework. It's not only for Spring Security, it's for Spring as an application framework, it's Quarkus if you are using Quarkus, it's Hibernate if you are using Hibernate. Whatever framework are you using, make sure that you know it very well. Continuously learn that framework. That is one of my advice I start with in most of my presentations. So today, when we say security, we refer to Spring applications. How many of you here use Spring? Okay, so almost all of you, I guess, and I can't see the online, but I guess you are raising hands as well. And when we say authentication and authorization, how many of you are using Spring Security for that? Only a few. So you will learn, at least you will learn something. I'm surprised, because Usually Spring Security is what you use for any kind of Spring application. Of course, we have alternatives, but Spring Security makes it very easy to implement anything today. I said I will structure the presentation in 3 parts, and the first of it we will start with the foundation, the very basics of Spring Security itself. But then the second part, we will focus on what applications implement nowadays in terms of authentication and authorization with Spring Security. So we will very fast, we will quickly go through the fundamentals, and then we will start part 2 of the presentation, where we discuss about OpenID Connect and the OAuth2 especially. I also added SAML on my list, but I won't have time for everything in a couple of hours, unfortunately. That's why I hope you will invite me again. And we will end our presentation with the third part, which is again a very relevant one. We were actually discussing a little bit earlier before the presentation, testing. And that's especially here integration testing with Spring Security. So if you'll follow me, we will deal into these 3 parts. Actually, I took out the Kahoot and I replaced it with unit tests, so we won't have the Kahoot anymore. And as I already told you, the best practice of the best practices is to learn well the frameworks that you are using. So let's start with the first part. So how is actually Spring Security structured? I don't want you to read what's here. I will tell you exactly what you need to know about what's here. So web applications only, it means that in case of web applications, you apply the Spring Security in a different way than necessarily for all other apps. And that's in terms of when you go down below in the structure of the framework, you will see that for web applications, we have 2 ways in which we apply the security. First of all is applying the security at the request level. That's the HTTP request. And if you will scratch the code, the framework's code, you will see that we have filters there. And it's a chain of filters intercepting the HTTP request. We talk about HTTP filters. So if you use Spring MVC, you know that somewhere at the end is a servlet that will be called, and that servlet has a chain of filters before. So Spring Security starts from the filter chain whenever we discuss about a web application. I'm especially, and I have to put a note here, I'm talking about non-reactive applications, because in case of reactive applications, it's a little bit different, and I won't gonna cover it during this presentation. But in case of normal servlet-wise application, we have a filter chain. After the filter chain, I will explain in detail later, we have the possibility to apply security in terms of, usually we discuss here about authorization rules using aspect-wise implemented security. That means that in case of Spring Security also activates an aspect behind the scenes that can intercept specific method calls, and those method calls then can be augmented with security logic. And here we discuss about global method security, where we have annotations such as pre-authorized, post-authorized, pre-filter, post-filter. We can have secured as well, but we don't use it, and roles allowed, but we don't use that anymore. So that's about web applications versus all apps. The idea is the following: Spring Security can be applied in any kind of application. It doesn't need to be a web application. We mostly find it in web applications because it just happens that most of the applications we implement today with Spring are web apps. And sometimes people even confuse Spring with a framework that you use to implement web applications, which is not necessarily true. You can use Spring. I used Spring, for example, to implement the context and dependency injection in a testing framework. So it was basically a Selenium-based framework used to end-to-end test a specific application. And of course, you always want to make the code as simple as possible. So one of the things that we did there was using Spring to use simple dependency injection. And Spring is modular, so you don't need to put everything there. you only add the dependency you need. In our case, it was the context and dependency, the context dependency, and we also used some aspects. So we added a Spring AOP dependency. So that's what I want you to understand is don't consider Spring an application framework for implementing web applications, because it's not only that. You can do a lot of more things. Think about Spring in terms of something an ecosystem that is very wide and that you can use in a lot of applications. And that's why Spring Security itself can be applied not only for web applications. It has this part that is aspect-wise implemented, which is literally for any kind of application you want. If it can be even a desktop application, and you can implement using it the authorization rules. So yeah, first part, and I told you that you don't need to read that because I have a second slide where you can see it better, is the filter chain itself. You can see in case of web application how the request goes into the filter chain, its purpose being reaching the servlet, which will then be redirected to a method behind the scenes. Those methods that you annotate with get mapping, post mapping, put mapping, request mapping, if you want to be more general. And it then goes out as a response. So you have the filters, and the filters usually are just the interface. They afterwards delegate to some managers, and those managers implement the logic, delegate to some other kind of objects, so on and so forth. So why do I show you this? This is because that's where Spring Security starts in a web application. So you need to have in your mind, understand exactly what happens there when a request enters the application. Where is the filtering happening? And in most cases, it will happen both at the filter level as well as at the method level using the aspect implementation. Why is that helpful? Why do you need to understand where the authorization logic acts? Is because depending on what you need to implement, depending on what authorization logic you need to implement, you would want to put it rather at the entry point, which is the filter chain, or you will want to put it later. And I will explain that again on the architecture. Okay, the all apps, we already discussed the fact that we have. The filter chain itself, I think it's important to consider the fact that it has an order of the filters. And I will tell you one thing that usually concerns and takes a lot of time to investigate if you are not aware of that already, is that being that the filter chain has an order of the filters, so it applies always the filters in a specific order. Of course, when we discuss about authentication and authorization, at the filter level, we have first of all the authentication filter, and secondly the authorization filter. So what happens in case you configure an application to have a kind of authentication, but at the authorization level you just say for a specific endpoint permit all. Usually the answer is whenever you call that endpoint that is marked as permit all, and we can do that right now in the code after discussing this very first part. You will be able to call that specific endpoint without needing authentication, because that's permit all. It means allow everyone enter and call this endpoint. But is there a case where this doesn't work in case of Spring Security? Well, the fact is that if you will actually try to call the endpoint using any kind of authentication that is wrong, even if the endpoint is permit all, Spring Security will not allow you to call it. So this kind of looks like a bug, but it makes totally sense, because even if it's permit all, the filter, the authentication filter in the filter chain is before the authorization filter. So it means that the authentication filter will always try to use its logic, and the request will never be forwarded in the filter chain to the next filter if the authentication doesn't succeed. So basically what happens is that if you use authentication for that endpoint, the authentication filter will try to apply the logic, see if the authentication is correct, and if the filter sees that you didn't use a properly configured authentication, or you simply used wrong credentials, whatever that is, it will reject the call without having the authorization filter looking into it. Which means that it doesn't matter that you configure the authorization at the endpoint level to be permit all, it will not be delegated. Keep that in mind. It might save you some hours of debugging at some point. It's usually strange to think about it, but it's because the way of the filter chain is the way the filter chain is configured in general. That's one of the points. So then the second is, of course, the architecture itself. What happens when you reached the authorization or the authentication itself? In our case here, we discuss strictly about authentication. So you see, what happens is that I usually see the filter chain on the horizontal, and then I see the logic on the vertical. So that's why my diagram goes down in this case. And I hope you can see it somehow. Maybe I can do something like this to show with my my mouse. So the authentication filter is, once the request in the filter chain goes into the authentication filter, the first step is being delegated to an authentication manager, because we discussed earlier 5 minutes ago that the filter usually delegates to a manager. So you have the manager that is implementing kind of the logic itself. What does in case of Spring Security is choosing an authentication provider. You only have one authentication manager, but you can have multiple authentication providers. And the reason for that is you might have different ways to implement the authentication. So if you have 3 ways at the same time to implement authentication, you will have 3 authentication providers. And then in case you need credentials, you will have a user detail service that is the object responsible with finding the user details, which can be finding them in a database, for example, or finding them through an endpoint call, or finding them in a file, I don't know. And then you have the password encoder, because usually the passwords are hashed, and when you store them somewhere, and that's very important, they need to be in a way in which they can't be reversed. And we use hashing functions for that. So like, for example, in our case, bcrypt. Most cases today we use bcrypt for that. Basically, the password encoder takes the password and makes sure that the received password on the request matches the hash in the database, or wherever the user details service took it from. And then when everything ends, and that's the most important thing from the whole diagram, so the rest 3 minutes maybe is not that important, but the most important thing in this diagram is to remember that once the authentication is over, if it's successful, if it's not successful, we already know what happens. 401 on the request, that's it. If it's successful, you will have the details about the authentication in the security context. So the security context is basically like a container in which you have all the details about who authenticated when a specific request was made. And the way Spring Security represents that, which is maybe not that important, and we will see it in the code anyway, is via the authentication interface, which is the contract that Spring Security understands as being either the authentication in progress or the authentication that has been authenticated already and is now stored in the security context, which, by the way, if you are thinking about now multiple requests at the same time, I'm not sure if you are thinking about that, and that's unclear, the security context behind the scenes uses a thread local. And if you don't know what a thread local is, it's just a simple object provided by the JDK that knows how to manage the information on separate threads, such that when a thread stores something there, only that specific thread will see that information. So that logic is not implemented by the framework, it's from the JDK itself, it's a thread local. You might have used that. If you don't, in a couple of sentences, that's what happens. So there are a few lessons that you need to learn very shortly before we go in the second part. I told you the first part will be short, and I hope you are not already very bored here, and I can't see you on the online. I hope you are not bored there as well. First of all, my recommendation is you always need to follow the design the framework provides, and that's honestly, again, it's important with Spring Security, but it is the same advice that I would give in any kind of a framework. If you don't do that, what happens is that either you might end up writing more code than you would have written if you would have followed the design. You might write code that is messier and more difficult to read. You might write code that is more difficult to find answers for on Stack Overflow or any online blog that you are usually searching. And you might even introduce, of course, vulnerabilities, because in case of Spring Security, it's about security. So don't forget that you can ask questions, and you don't have to do that online. You can ask them directly, so just raise your hand. I'm sure you were watching the stream online. Okay, so if you have any question, again, I'm answering them during the presentation, so don't hesitate to ask your questions. You don't have to wait up to the very end. So learn very well what the framework can do for you. One of the biggest mistakes I've seen with Spring Security is people trying to implement again things that can be out of the box used with the framework. So I do remember, and I think it's one of the stories that you will find also in the book, in Spring Security in Action. One case of a company for which I've made a series of sessions for consulting. And what they implemented, they basically had a very large application. I would say hard to understand, and they wanted that big application to make it cleaner and then separate it in multiple services. But the problem, one of the problem was the way they implemented the authentication. What they basically claimed is that they were using Spring Security, and they were using Spring Security. Actually, if you were looking in the POM XML file, you would have seen the dependencies for Spring Security there. The problem was that they were basically having the dependency for Spring Security, and then they were just defining some custom filters in the filter chain, because that's something you can do, and they were basically rewriting completely the authentication and the authorization. That is even the HTTP basic, for which we just literally have one line of code. You don't need to rewrite completely HTTP basic. So you just configure a user detail service, a password encoder, HTTP basic in the DSL method in the configuration file, and that's it. Don't do that. So try anytime you have a situation where it seems that you work more or it's more complex than it should be when writing code, especially with Spring Security. It might be a sign that you are on the wrong track. It might be a sign that you don't use something that Spring Security has already, and you can use that without having to rewrite it yourself. So in my experience, Spring Security is very customizable. It's highly customizable. It has some pitfalls, but they are not big, and people know already these pitfalls. But in general, it is highly customizable. So if you tend to have to write a lot of code to implement something that doesn't look to need that long code to be implemented, maybe you want to take a step back and see if maybe something online, a resource can help you see how others implemented that, and maybe find an easier way than make it very custom. Spring Security has some mechanisms, some protection mechanisms that it enables through the filter. So some simple examples being the CSRF, for example, the course is also. I saw people disabling them. They are enabled by default. usually disabling them is a mistake. I don't say that's always a mistake. I say that whenever you say something like HTTP CSRF disable, make sure that you know what you are doing, because usually that filter is enabled by default for a strong purpose. Even when it needs to be disabled, so as in a situation of using a token, like in case of OpenID Connect that we will discuss immediately, it is disabled by default by Spring Security. You don't need to write that line yourself. So if you write that line yourself, something is wrong in your configuration. Okay, so that's the idea, and that's my third point there that says don't disable the default enabled capabilities that the framework provides. Meaning, of course, if you do disable CSRF or anything that is by default enabled, make sure you know that you might, or what you might introduce in terms of vulnerabilities in your application. Real world implementations. Now, I don't want to discuss, I don't want to take the opportunity you gave me today to discuss all about HTTP basic, permit all, and stuff that is very, very theoretical. You can find it in the first chapters of the book. Let's discuss about things that are maybe 90% the case you'll implement, maybe even more than 90% the case, well, what you'll need to implement today in real world applications. And when we discuss about Spring Security and authentication and authorization, in most applications today we'll either have OpenID Connect, maybe we don't have OpenID Connect, but we have OAuth2. OpenID Connect is a protocol that is built over OAuth2. So when you use OpenID Connect, you use OAuth2. But when you use OAuth2, you don't necessarily use OpenID Connect. That's why I always advise people to understand actually OAuth2 rather than OpenID Connect, because OpenID Connect is just a protocol, meaning it imposes some rules over OAuth2. And in some cases that are much rarer than OAuth2 is using SAML. Spring Security has the possibility to implement all of this usually very quickly, and we will even implement one ourselves to understand better. Let's go into OpenID Connect and OAuth2. I will say OAuth2 from now on, because whatever we say, whatever I say here applies for OpenID Connect as well. Of course, the reason we need this kind of an approach, one of the reasons we need this kind of an approach is the fact that today we use a lot of applications and we don't want to have the same number of the same set of credentials for all the applications that we use. And that happens in any organization. I'm pretty sure it happens for you here as well. You might use Jira, you use Confluence, you use plenty of other applications. And all these applications, when you do log in, you use the same set of credentials, because it's not Jira, is not Confluence, is not the application itself that manages your credentials. Is a separate application that we will call from now on authorization server. And that authorization server, that's the one managing your credentials. And we have plenty of ways to implement an authorization server. It can be a custom implemented authorization server in the company. It can be an open source implementation, for example, as Keycloak we will use today. It can be something in a cloud, like Cognito or something else. The idea is you have one application managing your credentials, and all the others somehow asking this application, is this guy who claims they really are? And the authorization server will say yes or no, and then based on the authorization server's answer, the specific application will know who you are, or will know if you didn't authenticate yourself correctly. The part of the authorization is actually in the app itself usually. That's why it's pretty funny, and I always found it confusing. Why do people call it authorization server? Because even if indeed is the server that helps you apply the authorization, it actually does authentication. So in the authorization server is the authentication part. The authorization is what you can do after the authorization server authenticated you. and the flow is not difficult and we will follow it. It's always about having a token, which the token is actually an access card. What happens is exactly what happened when I came here. I went to a reception desk, I proved who I am using an ID, and I got an access card. The exactly same principle is used by OAuth2, and a very similar principle is used by SAML, but again, I will strictly focus on OAuth2 just to not lose our focus and go on multiple threads at the same time, which would make things more difficult to follow. Still no questions out there? Okay, cool. So it means it's pretty clear then. The purpose of an application is to get an access card, same as I did when I entered this building. And to get an access card, the application will have to identify itself. That's why always an application has a set of credentials itself. And that set of credentials is called, just to not confuse them with username and password, they are called the client ID and the secret. They are a username and the password, actually. And it's how the authorization server understands who an application is. One of the confusions I see is in the OAuth2 flow for someone starting to learn OAuth2 and OpenID Connect is what's the difference between client and secret and username and password. It's simple actually. Username and password is of the user, and client and secret is the way the application proves that that application the authorization server knows. Because the authorization server will never be allowed to provide the service of authentication to any application. Whenever you want an application to get the possibility to have its users authenticate through the authorization server, the application itself has to be registered in the authorization server. So the authorization server needs to know who that app is, and only an app known by the authorization server will be able to get the credentials and use the authentication process. So there are a lot of kinds of tokens out there, but one of them is the token of them all. That's the JSON Web Token. So again, I'm going to be quicker than I'm in a usual course because I can speak about Spring Security for a week if you have me here. But the idea is that you don't necessarily need to know everything about all the tokens. I have a lot of more details in the book. You will hear about opaque tokens and non-opaque tokens. Have you heard about these concepts before? What do they tell you? What could an opaque token be, and what could a non-opaque token? I'm starting the questions because I see you don't have. So, okay, that's opaque or non-opaque? If they contain information. If you can read this non-opaque, of course, yeah, the name is pretty significant. This is a non-opaque token. JVT is a non-opaque token. Even if it's encrypted, it's non-opaque. Maybe you have some knowledge and you might ask yourself, can this information be encrypted? And if yes, is that token still non-opaque? Yes. So when we classify the tokens in opaque and non-opaque tokens, the non-opaque tokens are those tokens where you can't find information at all. It's simply a string generated somehow, we don't care, it can be anything, but it doesn't contain any kind of information that's useful inside it. JVT is a kind of token that we call non-opaque because it contains information. It's actually made up of three parts that you can see here: the header, the body, and the signature. Well, the information is in the header plus the body, and these two parts are only separated for an organization purpose. It's not really important. You can add claims in both sides. You can add claims in the header or in the body, but you will usually, by convention, add the information in the body and only metadata in the header, which makes sense. Both sides, the header and the body, which contain the information of the non-opaque token, are signed. What does that mean? What's signed? What?
If someone has the signature, can unfold the token and can read the data.
if someone changes either the signature or the data inside the token, they don't match anymore. So anyone, absolutely anyone, can prove if a token was altered or not, if any of its content has been changed after it has been created. The signature helps us see that. So it's basically impossible to cheat on a token, on a JVT. Because what happens is that the issuer of the token, which is the reception desk, in this case, the authorization server, of course, who is the reception desk. So same as I got the access card. I don't have the access card with me, but that access card, now I can't do anything with it. I can't, if the access card doesn't allow me enter that door, I can't make it somehow, I can't change it somehow to allow me enter that door. And the same with the JVT token. You can't, if the token tells you roles admin there, and you want to add another role, say I'm admin and I'm also manager, whatever the roles are in case of your application. If you do change that, then the signature, that hash that has been created using a cryptographic algorithm, will not match anymore. And it's very easy for anyone, and that anyone is of course the applications using the token, to say this is a non-valid token, it might have been altered by someone, and I don't use it because I don't trust it. So that's what creates security. I have two questions. George, will you use the new authorization server from Spring? Yes, I will use it. I will use it because part of the code that composes is written by me, so I will use it. I do trust, if the question is, do you trust the new authorization server from Spring? Yes, I trust it. But at this moment, I can't say that I will use it tomorrow in any project. I'm literally waiting for this authorization server to get a bit more issues solved in its Jira board before I will put it in the next edition of Spring Security in action. And before that I will also use it. But yes, I trust this is a project. First of all, this new authorization server, for those of you who don't know, so Spring Security changed maybe 4 years ago, 3 years ago. And the way in which we configure OAuth2 has changed completely. The guys wanted it was an external project, and they wanted to put everything somehow inside the Spring Security itself, which makes sense. So to have everything in terms of authentication in Spring Security, and so that was the purpose of the change. The problem is that they changed this and they implemented only the what we call the resource server part in Spring Security via a DSL method that I will use, and they didn't, or they released everything as being production ready before changing the authorization server, before creating an alternative for the authorization server. So they basically completely deprecated the old project. They didn't provide at all an alternative, and that caused a really mess of confusion in the community, because people started to wonder, what shall I do now? Shall I go for Keycloak and don't use at all Spring to implement my authorization server? What if I can't do that? I had situations with clients who didn't, their I don't know, decision makers, stakeholders, didn't want to use Keycloak or some existing already authorization server from a cloud. They wanted to implement their own. For some reason, I don't care. But I do have to act on that. If they say, they are my client, if they say I want to do that, then what's your advice? Should we use the old authorization server? It's deprecated. Should we wait for the new one? We can't wait that long. Should we implement ourselves the same framework? Of course no, because it makes no sense. I mean, if you do that, you will have more chances of introducing vulnerabilities rather than if you wait for something or use something existing. So it caused a big mess. So I'm pretty happy that now we have a first version of this authorization server, and I'm pretty sure it will be used a lot, the new authorization server. But it's only a few months earlier since it's been released and as a production ready version. So I still, in my perspective, I always waited a bit more until I really used it. Fortunately, I didn't have any requirements for using it, but hopefully in the next months I might get some, and then yes, that will be my goal for sure. How the OAuth2 protocol works with Azure AD. It's actually OAuth2 is a framework, not a protocol. OpenID Connect is a protocol over OAuth2. When I say framework, don't think about framework as Spring. Spring is an application framework. In this case, when we say OAuth2 is a framework, we think about a specification framework. So it's a specification actually. Then I hope that was one of the confusion clarified. How does the specification work with Azure? The same as it works with any kind of authorization server or resource server fulfilling the specification. So you can't say that something is OAuth2 if it doesn't fulfill the OAuth2 specification. Azure AD, for example, implements its own service as an authorization server, implementing the specification. So whatever we will implement here ourselves, you will see basically it's the same as what is in Azure. Cool. Can we make Tomcat servers as an authentication server? So Tomcat is basically a servlet container. With the new authorization server, if you use the new authorization server and you use Tomcat as a servlet container, then yes, it will become an authorization server. And then one more question, how do we get the key to verify the signature? I will show you that. Let me put that in queue, because the next slide I have for you here is about the flows. And once we finish with the flows, because I want you to at least theoretically understand them well, we are going into coding a bit with Spring Security, the very simplest application that allows us use that. So this, what you see here, let me see, it's not written anywhere, but I can tell you this is the authorization code flow. This is called the authorization code flow, or in OAuth2 terminology is also called the grant type. And you should remember this notion of grant type, because you will see it in code as well. So when we say a grant type is one of the flows that any application can use to get a token. Let's say directly a JVT. It's a token in general. It doesn't have to be a non-opaque one, but in our case it will be a JVT, and in 99% of the cases it will be a JVT. So we can refer from now on to having a JVT. Well, in this case, let me take the steps one by one, and I'm specifically discussing the authorization code now. Grant type is because this is again the most used grant type. Some of them are even not recommended. I will enumerate them later. But from my perspective, what any software developer should know is at least the authorization code grant type. And that is the following. You will recognize these steps. You maybe have seen them daily. As a user, you want to use an application, Jira, or any other Atlassian application. Do you want another one? We can use any one. It's almost all of them use either OAuth2 or SAML. What the client does, what Jira does, is redirecting the user in the browser to the authorization server where you have to log in. If you already logged in, you will not have to log in again. That's why using this approach, you can implement a single sign-on, meaning you've signed on in AAD already, or whatever you use, Azure AD. And then whenever you change the application, you don't need to log in again, because already Azure knows about you. You have proved who you are. It might have a time in which a timeout where you have to log in again, but for a long time, you will not have to log in again when you change the applications. So let's take the first case where you didn't already log in. You will be redirected to your authorization server, and then in the browser you will have to put your credentials, username and password, and that's very important, in the authorization server, not in your application. So if you are using Jira, you don't put your credentials in Jira, you put them in Azure or whatever you use. So I'm just saying Azure because I've seen that Azure there. It can be any authorization server. If the credentials are correct, Azure will redirect back to your application, providing what we call an authorization code. So that's why the name of this grant type is authorization code. It provides an authorization code which is not the token. If it would have been provided a token directly, we would have called this the implicit grant type, which I will tell you immediately why it's deprecated. You shouldn't use it anymore. And anyway, the authorization servers have it disabled by default. It's vulnerable. But let's finish with this authorization code grant type. So redirecting back, the client gets an authorization code, sends another request to the authorization server using that code, and finally gets back a token. That is the JVT token. That is the access card. Now, the application can use the access card to call the backend, any endpoint on the backend, and get a 200 OK success or 403 forbidden in case that token has maybe a role that doesn't allow them calling that endpoint. So mind that once you get a token, it doesn't mean you can access any resource of the server. It means you can access only those resources that are authorized properly for that token. It's like when I get an access card, I can't open all the doors here. I will be able to open some of them, depending on my permissions, but I won't be able to open all of them. The same concept here. Very easy. So I was telling you that we have multiple grant types. Implicit and password, you shouldn't use them. In case of the password grant type, is a debate there. You can theoretically use them if you trust the client, but it's pretty rare the case. So that's why in my presentation, it's usually the password grant type is an X as well. The authorization code grant type is what you should use instead of the implicit grant type and the password. The authorization code with PKCE is a special deviation from the authorization code grant type. I will explain. It's basically solving a pretty small vulnerability the authorization code has. And the client credentials is the grant type that can be used by an application when it doesn't need the approval of a user. Is that case of a situation where an app has to communicate with another app. Maybe in the backend, you have multiple services, you have two services, they have to call one another. In that case, you don't have a user. How can you implement OAuth2 there? With the client credentials grant type. It's designed specifically for the case of having a call between the applications without the user. You can have a very simple use case. You have your application deployed in Kubernetes, and you have an endpoint exposing for Kubernetes the readiness and the liveness, the probes. Say you don't want to make those public, you want to make them authenticated as well. How can Kubernetes call the readiness and the liveness probe? You can, if you have OAuth2 and you specifically want to use OAuth2, then one of the ways to do that is using the client credentials grant type. Kubernetes doesn't need to ask a user to call the liveness endpoint. It can't do that. So it needs to be some kind of grant type that an app can use with and not need the user permissions for that. Where are the vulnerabilities? I'm showing you two grant types, and then I'm going to code. Please, because grant type refresh. Yes, you are. So one of the things that you might see here is that I didn't put all the grant types on this slide. So thank you very much for the question. The question is, what about the refresh token grant type? The refresh token grant type isn't here. I'm going to talk about it when coding. It is a way in which a client can get another JVT token without asking the user again to authenticate. And that's very important actually, because in a real world application, a token, a JVD token, might be used for 30 minutes, 1 hour, is configurable, but usually say 1 hour is a good time. It has to expire, not very often, but also quick enough. Say it's 60 minutes configured, like in a lot of cases. What you want is that your user won't have to authenticate every 60 minutes, because it's crazy, okay? It's not comfortable from the user experience point of view. You can't every 60 minutes ask the user login again. So what happens is that when it gets an access token, the application also gets a refresh token. And then the client uses that refresh token to get another access token and another refresh token, and it iterates over the same flow again and again. That's okay, it's a recommended flow. Why I didn't put it on my list here is because I wanted to discuss here specifically about a login flow. So that's why it's not on my list, but it's pretty used. Thank you very much for the question. What you don't see also here is the device. The device grant type. It's a situation where you want some kind of client without the user interface to authenticate. So if you have a smart switch or something like that and you want to authenticate with OAuth2, you can do that via the device grant type, which again is a detail. I won't go into it. There are some things that I skipped in the presentation to make it shorter, but please do ask the questions if you see something or something is unclear. What I wanted to tell you is why are these marked with an X on my slide? I'm pretty sure I wasn't clear with that. The implicit grant, the password grant type. The password grant type is that one in which the user puts the credentials directly in the application. So imagine instead of being redirected to Azure, which is your authorization server, Jira will ask you the credentials itself. If it does that, and then it sends the same credentials to Azure to get a token, that's called the password grant type. Why is it not recommended? What is the vulnerability with this flow? Well, the client sees the credentials. The question is, do you trust the client see your credentials? Maybe yes. If the client and the authorization server are part of the same organization, maybe you trust the client get the credentials and send them further to the authorization server because you know both applications. But you will never see this grant type available with a public authorization server. If you want to implement login with Facebook, Facebook will never allow you get the user credentials because it means that that client can get your Facebook credentials and then someone can get them and use them to hack your account. Same with any other public authorization server. So that's why here is the vulnerability. Secondly, if the client memorizes, stores somewhere the credentials, do you trust they store the credentials safely? Maybe yes, maybe no. So that's why I said it's a debate. When we talk about the password grant type, it's a debate, but I wouldn't match it as one of my recommended grant types. The implicit grant type is even worse. Maybe you are asking, and many people ask me, when I present the authorization code flow and I say here, the client authenticates, and then instead of getting the token, they get a code, and then they have to use that code to get a token. I mean, why? Doesn't this look a lot strange? And the answer is that it's actually the implicit grant type was the first. But what the implicit grant type has as a problem is that here everything happens as a redirect in the browser. So from these arrows, maybe it's not clear, but everything happens in the browser. So the problem is that because this is a redirect, you can very easily hack the browser to redirect the token to a different website. And then that website can take the token, and the token is the access card. It's very important. It's the most important piece of the authentication we know of. Having the access card, you can enter doors. So instead of getting directly the token, you get an authorization code, and then the client will make a request and get a response which is not via a redirect. So the big difference, there are two big differences here. One of the differences is, one, when you get the access token, is not a redirect anymore, so it's much more difficult to hack. The second one is that when the client sends the authorization code to get a token, it also authenticates itself again. So in order to hack this, you would have to steal somehow the client credentials, which is possible. But it's still less likely than the implicit flow, where you don't need the credentials at all. You just need to make the browser believe that website is another one. That's pretty easy to do. Any browser plugin can do that. Very easy to hack into someone using the implicit flow. You might ask, okay, cool, but what about the vulnerability we have in the client, in the authorization code grant type? Because I said, okay, if you get the client credentials, you can still do that. You get the authorization code, and then you use the client credentials, and then you get the token. Can we get rid of that as well? Yes, it's called the PKCE. That's a way, a very smart way, and that's what I actually recommend you use in any real-world example. You can use the authorization code grant type, it's safe. But if you can use it with PKCE, it's even better. It's a very, very small change. When this call is made to the authorization server for the login, the client generates a random information, a random string, something random, something that is difficult to, is impossible to find. And instead of sending that random, it hashes it using a cryptographic algorithm and sends the hash over the line. You know the very important characteristic of a hashing function. Whatever you hashed, if you have a hash, you can go back to the input. So if the client sends here the hash, what can we say about someone intercepting the call and getting the hash? Will they be able to get the random string that has been used to generate the hash? No. So that's why on the second step here, when asking for the token, the client, to prove who they are, they send the real input. So in this case, if someone intercepts this call, they will find the hash, but they will not be able to make the third call, because using the hash they can't get the input, because that's the definition of a hashing function. So here the client will use the real input, out of which have initially created the hash code, the hash string. And that's why using authorization code with PKCE is basically the strongest approach you can get. Okay, I'm pretty sure I'm too much of discussion and you are already bored. What I have here is a Keycloak that I'm already running on my machine. And the latest version of Keycloak, for those of you who didn't find out already, I did find out very few days ago, is that is now using Quarkus, which is a nice thing. But the problem with using Quarkus is that it also has a lot of bugs. So you can see a very nice null pointer exception here as well. Don't worry, we will go over it. What we want to do here now is, first of all, obtain a token from Keycloak and then implement an application that uses it. Should we start with the token or should we start with the Spring Security application? Guys in the room, what would you like? Cool. Let's create a new project. DD from Deloitte Digital and then Spring Security, and I don't think we will have more examples, but let's say E1, and I'm usually using the latest version, which is 17, although it doesn't make a lot of difference here. We have the web dependency, we need the Spring Security dependency, and we will also need the OAuth2 resource server dependency, because what we are making here is a resource server. The resource server is the definition for the backend. The backend itself is the resource server. So let's start my IntelliJ here. And let's create a very simple endpoint for the beginning. Okay. And you know how to create an endpoint. You can tell me the code. You can have a controller. And we need, of course, to annotate it with REST controller. Let's have an endpoint. And we use get mapping, and maybe we can even define a path here. Okay. If I'm running this application now, will I be able to call the endpoint? No. Why is that? Exactly. So by default, Spring Security with Spring Boot, it's actually Spring Boot, not Spring Security. Spring Boot sees that you have the Spring Security dependency, and it basically creates an HTTP basic by default configuration. It uses a user detail service with a random generated password. So we need to actually configure it. I won't prove that again. You trust me, that's the case. We need to configure it, because if we don't configure it, then we won't have a chance to call this endpoint. So what you can do is define a configuration file. Let's call it security config. And when people ask me, do you actually call it security config in a real world application? Yes, I do. And in general, in any application, generally what I do is I have multiple configuration files, and I do separate the configurations based on their purpose. So if I do configure something related to web, I create a separate file than the security one. I do recommend you do the same. We need to use the configuration annotation, and then we need to extend web security configurer adapter. And extending web security configurer adapter will give us the chance to override the configure method that we will use to write our configurations. Where it is? Here it is. Mind, there are multiple configure methods. What we need is the configure of HTTP security. And whenever you want to, there are two main things you do here. Okay, you can do multiple things. You can disable CSRF, you can do a lot of things here. But the idea is you have two main things that you really need to do here. One of them is set up the authentication method, and the second one is set up the authorization at the endpoint level. So when you say authorize requests, and then you specify using matcher methods which request do you want to authenticate or not, then that's the authorization configuration. Usually I prefer before that to say HTTP and use the OAuth2 resource server DSL method, which in this case configures my Spring Security application to use this application as an OAuth2 resource server. We still didn't finish, because if you are now thinking about how does my application know that a specific token is correct, then you are right, we didn't provide any information about that. So what we will have to do, and the only thing, and there are multiple ways to configure that, but the most practical one is to use what's called the key set URI. What is a key set URI? If you are going to Keycloak back, so I have my Keycloak running. you will see that Keycloak as an authorization server can provide you ways to authenticate through OpenID or SAML. And we are, of course, interested in OpenID. So if you are clicking this endpoint link, you will get the configuration you need. I would have preferred to be easier to read, so let me try using a JSON formatter to make it easier to read. Okay, not very large enough, but this is it. So you will find here a lot of things that will basically tell you which is the configuration, what grant types are supported by this authorization server, which are the endpoints that you can call to get a token or get authorized. These are basically the endpoints you need, and they are, when any authorization server, it doesn't matter it's Keycloak or some other, will have this kind of configuration endpoint, and you will get, and maybe three most important endpoints here are this one, which is called the authorization endpoint, is the one used by the client to redirect to the authorization server. We will manually do that. I have this one here, which is the token, is the one that the client will call to get a JVT token, and is the key URIs, which is the one we will configure now, as this one here, which I would like to call it before. Wow, this is kind of a bug, I guess, but let's see if it copies. So I want to put it in Postman and see what happens. So you see it's an unsecured token. Is there a way I can make it a bit larger? I want to keep that. So this is how it looks like. It's a set of keys. Every object in this JSON representation is a key, and the most important thing you have here is the key and its identifier, which is the key ID, which is unique. So what we are actually doing, we will take this endpoint completely, the one that we just called with Postman, and we put it here in our application. And mind, it should be in a properties file usually, so don't put URLs like this as I'm doing here. It's just for my demonstration to save time, but whatever is configurable, it should be in a configuration file. Whatever is secret, a password or a private key needs to be in a vault. That's a rule, okay? But I will work with this, it's fine. And what I'm doing here is I'm telling my application, these are the keys that Keycloak will use to sign the token. But that's not totally true. Keycloak doesn't expose the key it uses to sign. That's what is called a private key. A private key is somewhere configured in my Keycloak. We can't see it. Well, I can see it because I'm the admin, but you can't see it as a non-admin. But it exposes the public keys. The public key is the side of the public-private key pair that allows you to validate the token. Having the private key, you can sign a token. Having the public key, you can validate the token. So having the public key, you can't do a lot of things. It's risk-free to expose a public key. That's why this endpoint is exposed. You can call it, is not authorized. If you get a public key, the only thing you can do is validate a token. So what I did here through this configuration is telling my application, these are the public keys that you can use to validate the tokens that are coming from this Keycloak authorization server. So that's how my application will know if a JVT token is valid or not. Otherwise, it makes no sense. Why is it more comfortable to put it as this URL instead of configuring the public key itself in the resource server? Well, you can do that. You can configure the public key in the resource server. But one thing, one practice that is very good is usually to rotate these key pairs from time to time. so that from time to time your authorization server uses different keys to sign the token. If you do key rotations, which is what I'm telling you now, it will be much more difficult to rotate the keys on both the authorization server and all your applications, rather than only rotate them in the authorization server. So it makes a lot of sense to have the authorization server keeping both of them and exposing only the public keys through an endpoint, because it makes you the process of the key rotation easier. So if I'm running this application now as is, how do I call the demo endpoint? Can I simply call my demo endpoint in Postman directly? I shouldn't be able, actually. There is one thing. I have keycloak on the same port. I wonder if even how is that possible. Let's change this to 9090. So let's change the port not to break something in my keycloak's configuration. And run it again. Okay. So can I call the demo endpoint now? Well, I can call the demo endpoint, but I need a token. If I will try to call it without having a token, I will get 401 back. So we can try that and prove we get a 401 back. .9090 demo, and we get a 401. And the reason we get a 401 is because we need a token, and the token is always in the authorization header of the request, prefixed by the word bearer. How do we get a token? Following the steps from OAuth2. Which was the first step? The first step is the client redirects the user in browser to the authorization server. So how do we do that? Well, we do use, where was it? Oh, here it is. We do use for that the authorization endpoint. So this authorization endpoint here, where we will have to, and I actually, just to make my life easier, I will copy it from here. We will have to specify what kind of grant type we use, the code, meaning we would like to use the authorization code grant type. The client ID, which should be a known application registered in the authorization server, and if you are going to keycloak, you can see in the clients that, oh, sorry for that, my session expired. Okay, you can see in here that I have the client my app. So it's basically a client that I previously registered. I didn't do a lot of things with it. I simply registered that client. So if I'm going here, the third thing that we have to provide is the redirect URI, meaning telling the authorization server where to redirect us back. In our case, it's redirect us to some URL. We don't care because we don't have a real application, but we will need to redirect us to somewhere so that at least in the browser we take the code. So let's take this URL exactly as is and put it in a browser. Just put it in the browser. So exactly as is, you put it in the browser. It of course tells you the page isn't working because I don't have an app on that localhost 9090. But I got what I wanted, which is the code. This is the code. So of course, in a real world application, this page would have existed, behind the scenes would have taken this code and would have made the post request to the token endpoint. We don't have an application here, but we can use Postman to prove that. Oh, how do I copy this? Okay. Almost there. Good. So I'm going to take this and I will put it in a Postman request to the token endpoint. Using the body, I will say code, and I will simply copy the code here. And then whatever else should I use? So the client ID, my app, I think it was. We need the redirect URI. We need a grant type. So we need to specify that we are using authorization code. We need the redirect URI, which is mandatory to be the same one that we use here. Okay. And I think that's no, we need also the username. So we need the username of the user who approved that. One of the users, theoretically, in my case, I will use the only user that I have on this keycloak. But it doesn't matter. It's always the user who logs in. And which is the URL? I should find it here, token endpoint. And if everything is fine, sending this, oh, method get, I should have used post, okay. Oh, you can only use the code once, so I already used it. Even if it was an invalid request, it got used, so I have to generate it again. So that's an important thing. The authorization code, once you used it, you can't use it again. And again, that makes sense because otherwise someone would be able to steal the code and reuse it. So now I got a different code and I could even copy it easier. And I will put it here. Okay, that's better now. So what you see here is the access token. This is the refresh token we were discussing earlier. And all of these two, both of these, they are JVT tokens. So if you take them, if you copy them and put them in a base64 decoder, you will see they are basically some simple JSON. So jvt.io is what I'm usually using for that because it's very comfortable. Just put it here. And what you see on the right is the token. And if you can't see here, let me make it larger, the font. This one here is the key ID in the header. It tells us which was the key from the authorization server that has been used to sign this token. If we are going back to that endpoint, maybe still have it here. Not this one. This one here. So in one of these keys here is the one that has been used. It's either, we only have two configured. It's either that one with Y or that one with JZ. Which one it is? The one with JZ. So out of the two keys, this was the key that Keycloak used to sign this token. It is important because what our application will do, it will call this endpoint, it will get both keys, and we'll need to know somehow which of the two or multiple keys exposed was used. So which of those will our app use to validate the token. And how does it know that? Through the header. That's the way it knows that. Other informations that you find, especially in the body, they can be changed. That means usually here we have the roles at least, we have the username, sometimes other kind of details. You can add custom claims here. The authorization server can be configured to add custom claims. And because you don't have necessarily a way in which this body looks like, you will also need somehow on the resource server side to configure your app to understand the custom claims. and that's something you can do with a converter, which is very easy in Spring Security. But the idea is that you can basically take anything from the information here, anything that's useful for you on the Spring Security side, and then use it in your authorization rules. So it's pretty easy to do that. So I have some questions that I didn't follow. Let's take some of them just to make sure we answer everything. Could you explain the differences between pre-authorized and secured? So basically secured, which is an annotation that you can use with global method security, has been implemented especially for compatibility purposes with J2EE. It's not something that I would recommend you to use, and it's less powerful, if I'm not wrong, and I hope I'm not wrong, because I didn't use secured a lot of times. You can only put conditions on roles and authorities on secured, while with pre-authorized you can use Spring expression language to add any kind of condition. So that's my answer. How an OpenID Connect user gets initialized if we have React.js as a front end and authentication to be done in Azure AD? So the user needs to be added somehow in Azure. That's an admin adding them there. The authorization server, whatever authorization server is, will need to know both the users and the clients. And then any kind of front-end application will basically use the flow that we are experiencing here, and we just explained earlier, to get the token and then use the token. I hope that answers the question. And then we have another question. It gives also the algorithm used for the authorization server to check again. Right, yes, that's a good point. So you see the algorithm used here. That's true, because it's possible that you use different kinds of algorithms. So depending on the algorithm used, the resource server might need to use a different way to check the token. So that's why you always have the algorithm in the header as well. How does the OAuth2 server know that the second value is original? I'm not sure what means the second value, but when we discuss about the token, any values here, whether they are in the header or the body, they have been signed. So if something is modified in between, then you would know, because the signature won't match anymore. Cool. So if I didn't correctly understand the questions, please just put them in another shape, and I will try to answer again. So we were explaining that we have the key, we know now the key ID, we know exactly what we need. So we have also a token here. Can we use this token now? Let's try to use this token. Okay, I hope it's important is all of it, because otherwise it won't work. And I'm going back in my Postman in the demo endpoint, and that here bearer, and copy the whole access token, and now it's working. I can't make it larger, but you can trust me that I have the body here and the code. So it's pretty easy. Implementing OAuth2 Spring Security, it's literally 10 lines of code, and that works with any authorization server. So I hope I still have time, because I talked a lot, and I still have 30 minutes, because I still have things to tell you. Now, we do have the possibility to add also authorizations in here. When I say authenticated, it basically means I don't apply any authorization rule. The only authorization rule is that the user is authenticated. That's why it's working. I could have used the access method, and then I can apply, and that's important, any authorization rule that is based usually on roles and authorities. But sometimes we need more than that. Sometimes we need a larger logic. And what you can do in that case is use the other way around of implementing the authorization rules. We started with that at the beginning of the presentation. In a web application, you can do both add authorization rules through the filter chain, which is that. When you put a rule there, it goes through the filter chain. Or you can put it through the aspect, and that goes at any layer of your application. You can implement it at the controller side, or you can implement it at the service side, and you can even implement it at the repository level. And Spring Security even has a good compatibility directly through the Spring expression language with Spring Data. So in case you are using, for example, Spring Data JPA, and you want to put the username on a query, you don't have to take the username and put it as a parameter of the method. The Spring expression language can help you inside the JPQL query directly add the authenticated user from there. Too complicated, I don't have a database here, but you have some examples in the book. What I wanted to say is that let's try also at the second way to configure authorization. To do that, you need to use the global method security, which is not out of the box enabled. You have to enable it. And here you have those annotations. One of the questions was about secured and pre-authorized. If you look into this annotation, you will see that you have multiple options actually. So one of the ways to configure through an aspect the authorization is using the pre-post annotations, which is 99% of the cases, and what I also recommend you do. These are 4 annotations: pre-authorized, post-authorized, pre-filter, and post-filter. We have the secured annotation, and we have the roles allowed annotation, which is the JSR 250, also imported for compatibility purposes with J2EE a long time ago, and I don't think I've seen many projects using it, and what I've seen were very old. So let's enable the pre-post annotations. You can do that by putting the attribute of the annotation pre-post enabled on true. And then once I do that, on literally any method of any bean in my Spring application, I can use pre-authorized, post-authorized, pre-filter, post-filter. So for example, pre-authorize, and then what I'm doing here, I'm going to say, oh sorry, let's use something simple, has any role, and I'm not even sure what roles I have here, but we will test them. Maybe it's even better test them before, because I didn't define them. They are from Keycloak, of course. I didn't change the configuration before the presentation. So do you know how you take the authentication from the Spring Security context in any place of your application? If you are at the controller level, you just define it here as a parameter, and Spring is smart enough to take it. If you are somewhere else, you can always say something like authentication, security context holder, get context, get authentication, and that's your authentication. Let's try debug it. So you see how it looks like. I'm just going to call again the endpoint in Postman. And difficult for you to see probably here. I'm not sure if I can make it larger. But here is the whole token and the map of all the claims in the token. So I'm not sure if I can copy that somehow. Maybe copy it here. Okay, this is what it looks like. So it's basically giving you everything on the JVT token. Everything that you saw here in the header and the body, you have in the authentication. So you can use either of the information here to apply authorization rules. Which are my roles? So it should be something with scope, because by default the roles are taken from the client roles, but I don't see them. Strange. Okay, authorities. Here they are. Scope email and scope profile. That's what I requested. Sometimes they are not enough. By default, they are coming as what the client can do. But you can always override them with, for example, user-defined roles if you want. Remember that Spring Security easily allows you to convert the token into any kind of custom authentication. The only thing you need to do to configure something like that is a converter. And if you want to configure a converter, you can literally add a converter here. It's called the JVT authentication converter. That's a class implementing the converter interface, override the method, and then implement whatever custom authentication you want. If we have time, we can do it together. So it's very easy. Because remember, I was telling you that you can have this in any shape possible. It's not necessarily this way the same. You will have it in Azure or something else, Cognito, whatever you use. Even in Keycloak, you can customize it. So you will need to make your application understand the token the way you get it. So if I'm going to add a constraint here, I can say pre-authorize scope email was one of them, I think. And if I'm restarting it, then theoretically this should work, because that's a role. And if I use any other role, it will not work. And that's it. Okay, 403. Scope email, or not scope email. Scope. Scope email. Okay, I think it takes it as not any role, but it takes it as an authentication, an authority, sorry. That should be the problem. Okay. Okay, that was it. So that one is working. It's a 200 okay. And going back, if I'm putting something else, you've already seen it's a 403 forbidden. And that's basically it. Still any questions? No? Okay. I don't have other questions in the audience online. And I would go to the third part of the presentation, which is testing your application. I think you observe it's pretty easy to configure the authentication. You have two very simple ways, straightforward, to configure your authorization. And now the question is, how do you test it? Is it important to test it? Yes, it is. Actually, I would recommend you test any integration in your application with a framework. When we discuss about Spring Security, we discuss about integration tests, of course, because what we test is the integration between our application and Spring Security. An advice from my side would be use integration tests for any framework you are using, even Spring itself and parts of the Spring. Why is that? Because frameworks change, and changing them, developers might make mistakes and make the things work differently than they were, for example, in the previous version. It happened to me last week. Last time I had a problem with Spring, upgrading from version 5.3 to 5.6. the Spring expression language taking a list of strings and putting them into a var args on a parameter of a static method changed from version 5.3 to 5.6. What happened with this change? Instead of splitting the values by comma and putting them as a separate element in the array, now all the string with commas was only the first element of the array and the next one were empty. I mean, it was basically an array with only one element. It didn't separate anymore the values by comma. The only change we made was simply upgrading from one version to another. We discovered this via the integration tests. That method, fortunately, was tested. And when running the tests were failing. So the tests related to the translation from Spring expression language of the list to the parameters of the method. And it was pretty easy to identify it, and it was pretty quick to solve the problem because we immediately through tests knew what the problem is. With security, it's even more relevant. If something changes with Spring security, it can happen that it even introduces vulnerabilities. So what do you always need to test with Spring security is at least the authorization rules on the methods. Anyway, there are two things that you mainly can test, is the authorization rules and the authentication. And if I'm going now to my next slide of the presentation, I will tell you that usually 1% is testing authentication, because you generally have in an application one way to authenticate. You might have multiple, might have 3 ways, 5 ways. Okay, how many authentication ways? A small number always. Usually it's 1. But how many authorization rules? Every endpoint might have its own authorization in a different way configured. So that's why usually you have more authorization tests rather than authentication. We will create some and go to the lessons learned later. Okay, so what I want to do is to make sure that this rule, that this authorization rule works as I desire it to work and stays like this. And I create a test for that. So let's go to the tests here. Usually you will have some nicer names for the test, and test demo authorization. Don't forget that with JUnit 5 you can use the display name annotation. So what I do see still is, and I don't like, is that people still write something like long names for tests, eventually separated with an underscore, and sometimes this large, this long, and you read as like sentences trying to tell you through the name of the method what that 50 lines of code test does. So in my perspective, with JUnit 5 you can even name them test 1, test 2, test 3, as long as you use the display name to explain in the display name. And don't forget that with Java 17 you can even use the nice, probably I don't have it set up here. Oh, sorry, let's do like this. You can even have the nice text blocks that allow you to put it in a way in which is very easy to read on separate lines without needing to have plus quotes and a lot of stuff. It helps a lot describing the test like this. Yes, I know it's not Spring security. So what can we do to test the endpoint? Let's say I'm using mock MVC. To use mock MVC with Spring Boot is very simple. You just add the auto configure mock MVC annotation. you declare and you inject via auto-wired a mock MVC, and then you can say perform a get or a post or whatever you have there on the demo endpoint. Okay, I will have to throw some exceptions here, I guess. And then tell whatever you expect. Say we expect status in our case to be okay. In a real situation, we would have more rules here. But I think for us it's just enough. Question, will this work? Will this unit test run? Or fail? Yes, correct. So we don't have any authentication. So if you run this, it should fail. Because this is returning a 401 rather than a 40, or rather than a 200, which is okay. So can we see that here? We should be able to see that here. 401, okay, which is clearly what we expected. We don't have the token. You have multiple ways to solve this. One of them is using, oh, sorry. Oh, sorry, with JVT. Okay. I hope they didn't change the syntax without me noticing. How do I import this? Okay, made it somehow. I'm not sure how. Sorry, I'm not used with my Mac. You can say with JVT that what happens here is that the JVT, it only mocks the authentication. So what basically this does is to put in the security context a mock authentication. So the question is, will this work now? Well, I'm still pretty sure it shouldn't. And that's because we will see one change here. The change should be from 401 to 403 of the status, I mean. So if I'm going here, I should see now that's no longer 401 but 403. But now it's failing not because of the missing authentication, but because of the failing authorization, which is this pre-authorized here. So if I would comment this out, for example, my test should now pass successfully. Because now, not having any authorization rule, it will simply expect an authentication to be present, and that should work. And it's working. But what do we do if we have an authorization rule? So going back here, let's say that, okay, let's say that we put it back. Well, in that case, you can use one of the 3 ways. I will only present one. You will find 3 ways in the book of defining a mock user. The simplest one being the with mock user. I uncommented that line. Now it should work and we should see this as a passed test. Okay, 2 questions, very short. User info endpoint, how is it set? I think we have already seen that. I hope you refer to the keys URL because I'm not sure exactly otherwise to what exactly. How did you add that role in JVT? I didn't add it. Keycloak added the role in JVT. If I'm going to my Keycloak, where is it? You will see that one of these roles should be here, and for my specifics for my client, you should have the client scopes here. Anyways, somewhere here. So I'm not an expert in configuring Keycloak, but it is configured somewhere in the authorization server. Email and profile, and that scope underscore is added by Spring Security. Cool. And you can also see them, I think, here. This is what Spring Security takes and puts in the authorities list. Why does the app still generate random password? That's a good question, actually. Did you observe that? I observed that. I actually saw that for many weeks. This is a bug. This is a bug in Spring Boot, actually. So that security should not be there anymore. If you really want to put that logout, you can disable the user details configuration with an annotation on a configuration class. That's the only way to do that. So what does that mean? It's actually because we use a different dependency. You've seen at the very beginning that I didn't only add one dependency. I added 2 dependencies in my POM XML. One is the OAuth2 resource server and the other is the security. Spring Security doesn't see that we configured something in terms of security. Basically, Spring Boot doesn't see that we configured something, and it's like it believes that it still needs to create that default user detail service. So it basically creates that user detail service in the context which nobody uses. It should be, in my perspective, disabled once you add this to your POM XML. Probably is somewhere in a Jira issue very at the bottom of the backlog because it's not that relevant. I mean, it doesn't affect you anyhow, just that you see that log line there. But indeed, you are right. So it shouldn't configure anymore the user detail service. This really is a bug in Spring Boot. And with that being said, I think we are almost done with the presentation. And let's go a little bit through the lessons learned again. And then let's see which other questions you have. And if you have some other questions, I can answer. And then, okay, we can, of course, quit. So, lessons learned. Avoid using the implicit and password grant types. I think that's now clear why. So you've seen in both of the flows, we have some vulnerabilities that you should avoid. Prefer using the authorization code grant type with PKCE. It's the difference between the plain and the PKCE authorization grant type. The authorization code grant type is okay, but with PKCE is better. If you have multiple apps, make sure that all the applications have a separate set of credentials, so they don't have they have different credentials. I've seen clients being or not of the same organization configured with the same set of credentials. That's wrong. I didn't go into detail, but if you have at some point to take the decision between using asymmetric keys, which is what I presented here, versus using symmetric keys, prefer using the asymmetric key pairs because it's easier to avoid a situation where you lose the private key. So in case of the asymmetric pair, the private key is always only stored in the authorization server side, and the public key can be made available to anyone, which is through the endpoint we've seen. And one thing again that I didn't that I didn't say, but it maybe makes sense, is don't add too many details into a non-opaque token. For example, in the JVT token, you've seen the many headers. Theoretically, you can put anything there, even the profile picture of the user. But the more things you put in there, remember that the token is exchanged. It's stored on the client side, is exchanged in every request. So it makes sense to be small to not affect the performance of the request. Secondly, the more information you put in the token, the more information needs to be signed. The more information needs to be signed, the slower the signing process is. So that's one more point where you can encounter performance issues from. So even if it looks sometimes comfortable, the token is not designed to put a lot of data in there. Try to only put what's really needed for your resource server. Yeah, I could have used this visual. I forgot about this visual I added. Maybe you want to take a look on it. What I usually try to make people aware about testing is what they literally test, because many don't understand, for example, why in this case of mine here, it's even in this case of mine, why did it actually work when I comment out the authorization even if I don't have the user at all? So what I want to say here is make a clear difference between testing authentication and testing the authorization. When you use the with mock user or the with JVT method, it means you skip the authentication at all. You don't test the authentication. You only test the authorization. So on a visual, what that means is that everything here is skipped. What you see is with gray here, this is skipped. Your test doesn't test the logic in all this. The test only gets a mock user from the security context, puts a mock user in the security context, and uses it throughout the logic. So it completely skips everything else. So when you do integration test, if you want to test the authentication, you don't do that with a mock user. You literally need to test authentication, which is usually in an OAuth2 environment done at with the system test level, so not with the integration test, because you need to take the JVT from somewhere. So you basically implement with Selenium or whatever you use a real call to get the token to the authorization server, like we manually did here, for example, in Postman, and then use that token to access the endpoints you want to test. Cool. In case you didn't consider yet, you can and you don't know about them, you can follow me on Twitter, YouTube, my blog, LinkedIn. And for you, first of all, we had the books. I think you already got some of you the books. Some of the online audience will get them later, of course. Then you have this Deloitte 35 code on Manning, which gives you 35% discount. The publishing house gave me this code for you specially. We have 3, I think, tickets at Vox Days for you. And we have also a discount at Vox Days if you want to find me later. If you want 20% discount to Vox Days, I will give you a code. I will share it on my YouTube channel as well with everyone. So any questions? Now it's the chance. We still have just 4 more minutes, but we can talk afterwards also if you want. Looking there at the online as well. Okay, no more questions. Then thank you again very much, everyone, for welcoming me here. I hope you will find the details in this presentation useful. And of course, I hope you will find me also in an online environment later, LinkedIn, Twitter, and so on, and we keep talking. So thanks. Cheers.